paper crumbled really good. So put 0.83 seconds. So we got to now go back to the solver. And we don't have to re-input the equation. Just go back and place everywhere that we use 2.5 for the t, put 0.83. Okay? So I'm going to go into my equation, and I'm going to delete, insert. I'm going to insert 0.83, right? Delete, insert 0.83. Just two places, right? Wherever the t was used. Enter, solve. B comes out 0.0025. Does that make sense? What was the B for the other one? 0.044. Yeah, of course. By crumbling it better, I am reducing the air friction on it, right? So the B should be less. And now put that into the V equation, right? So put the new B into the V equation. V of 0.83 seconds. What was that? BT, so. This one comes out to be 0.30. So what does that mean? That means the crumbled paper, by the time I dropped it from 3 meters and it hit the ground, it reached 30% of its terminal velocity. So this one, it's gonna, if you let it fall longer, it's gonna keep accelerating until it gets to the certain time when it begins to approach its terminal velocity asymptotically, you know. So it's only reached 30% of its terminal velocity. So now we multiply this by a 0.0057 multiplied by 9.8 divided by 0.0025, 6.81, 6.82. Now, is that less than the velocity of a free-falling object? Yes, huh? It's beautiful how it works out. It's a little bit less than the free-falling object. Nice. This is how I like results coming out. Okay. Now, how about for the sake of fun, how about if we try to trick the equations and we said t is equal to 0.63 seconds. What's going to happen? Now, the reason why I'm giving this as an example is because I'm giving a time that is less than the time for free fall, 0.78 seconds, right? So if I try to trick the equation to give me a solution to this now. So go back to the equation, change it 0.63, look what's going to happen. See, the physics will come the winner every single time. You'll never be able to trick it. So I went in and I tried to place everywhere where there was a 0.83, I put 0.63. So now I get a B, but my B is negative 0.01, right? So what does that mean? Why is it giving me negative? Well, it's telling you the only way you're going to be able to beat free fall is if the friction now turns around and pushes you down. Okay? So if the B is negative, that's what's happening. The friction is pushing you down. But can that ever happen? No. So this thing will never occur. You see? So the equation has that built into it already. It knows that the fastest time is 0.78. Now, how does it know that? Well, because in the derivation of the way I derived the equation, it has that built into it. So go back into the derivation of the equation, see how that's built in. How about if I put a time of 0.78, what is it going to give me for B? It's going to give you 0 for B. Or it's going to give you some number that is very, very small, 0.00000000895 to something, you know. So it's a very smart equation. You can't try to trick it. Okay, good. So with that